All right, we're looking at the bottom of page 3. Number 7, a monkey is sitting on the limb of a tree. A hunter points a gun directly at the monkey. At the instant the gun flashes, the startled monkey falls from the tree. Does the bullet hit the monkey? So you might want to pause and draw this picture. You're going to want to draw it. But here's what happens. At the moment that the hunter fires the gun, this monkey starts falling from the tree. And so let's say it's here. So the monkey has fallen by this much. So basically what happens is here's the monkey falling. The hunter was sighting straight down the barrel, and this was the original line that the bullet would follow. Does the bullet hit the monkey? So the monkey is being accelerated downward by gravity, but the bullet is also being accelerated downward. And so it's not following the straight path. It starts off straight, and then it veers down, and there it is. So does the bullet hit the monkey? And the answer is yes. Gravity accelerates the bullet and the monkey downward at the same rate. So number 8, a baseball leaves the bat at an angle of 40 degrees at a velocity of 30 meters per second. Find the values of the vertical and horizontal values. So here is, let's draw a picture first. Here's our 30 meters per second. Here is Vx, and here is Vy. And the angle for this one is going to be here at an angle of 40 degrees is really talking about from the horizontal, because that's the angle we would look at the ball going up instead of going straight horizontally. So when we want to know the velocity of x, we're looking at a triangle basically here. This would be Vy. Looking for Vx, we have an adjacent side and a hypotenuse. So we're looking at, we need cosine of 40 degrees equals the horizontal velocity divided by 30. Or you could skip that and say Vx equals 30 times the cosine of 40 degrees, which is 22.98 meters per second. To find the vertical velocity, we use the sine of 40 degrees because we have an opposite and a hypotenuse. So vertical velocity is 30 times the sine of 40 degrees, which comes out to 19.28 meters per second. B, find the time it takes for the ball to reach its maximum height. So here's what happens. The ball is going to follow a curved path like this. We know that as it first starts going upwards, its velocity is 19.28 because we found that here. Which means that as it hits the ground, its velocity is also 19.28. Remember, throwing speed equals catching speed. And we are looking for how long does it take to reach the maximum height. So here is your basic formula. Velocity final equals velocity initial plus the acceleration of gravity times the time. And if the initial velocity is 0, then the velocity equals the acceleration times the time. So we know the final velocity, 19.28. We know the acceleration of gravity. Let's keep my units. We know the acceleration of gravity, it's 10 meters per second squared. And we're going to solve it for t. So we know that time is 1.928 seconds to go up, which means it reaches its peak at time equals 1.928 seconds. Find the total time of flight. So we know that it went up for 1.982 seconds, and it's going to take an equal amount of time for it to fall. So its total flight time is 3.856 seconds. How far from home plate should the fielder position himself to catch the ball? So remember, we have 4 basic things that we look for. Distance in the x, velocity in the x, distance in the y, velocity in the y. And here's a basic picture of what we're doing here. So this ball is hit and it's going to travel in a path like this, and the fielder is going to catch it over here. So remember, as it goes up, its horizontal component remains the same, but its vertical component is becoming less and less. So what we want to know is how far from home plate, that's dx. So here is the formula that we want to use. Horizontal distance equals horizontal velocity times the time. So we know the horizontal velocity. We already found it here. 22.98 meters per second. And we know the total flight time. We found it in part C. That is 3.856 seconds. So this ball is going to travel 88.6 meters, which means he should position himself 88.6 meters from the plate.